I am Sabrina Gonzalez Pasterski from Chicago. I have flown since the age of 9, and my Cessna 150 is based at Pewaukee Airport, located in a small keyhole cut out under O'Hare's Bravo airspace. It is simply a matter of time until terrorists utilize a dirty bomb as a method of attack. My goal is to convince you that more can and should be done right now to detect and deter dirty bombs. As an aviation enthusiast, I fear what the future of general aviation would be if an aircraft was used as a method of delivering a dirty bomb. I do, however, see infrastructure already in place to detect and deter dirty bombs. During the past months, I conducted experiments to determine if man-made concentrations of radiation could be detected from an aircraft equipped with a Geiger counter. You will be pleased to learn that yes, a light single equipped with a Geiger counter can, to a 95% certainty, discern marked fluctuations in radiation from 1,000 feet AGL. Reviewing the administrator's most recent figures on single-engine aircraft, there are 160,000 airworthy aircraft that fly 20 million hours each year. These aircraft are scattered throughout the U.S. and fly approximately 5 million hours a year between 1,000 and 2,000 feet AGL. Of these 160,000 aircraft, 100,000 are transponder equipped. There are 3 types of radiation we encounter each day: terrestrial, cosmic, and man-made concentrations. Terrestrial radiation in the Great Lakes region averages 1/5 of a microsievert per hour. As you leave the ground, this radiation diminishes rapidly, but cosmic radiation increases. Radiation levels are moderate at ground level. They decrease to a minimal level around 500 through 2,000 feet AGL. Around 7,000 feet AGL, radiation levels reapproach terrestrial levels and then climb with altitude. 10 times background at 25,000 feet, 15 times background at 35,000 feet, and so on and so forth. Military and commercial flights are conducted at too great of a speed and altitude to be able to detect fluctuations in radiation. Buildings and terrestrial radiation interfere with ground-level Geiger counters used by authorities. Low and slow aircraft, general aviation, is well suited for such detection. My proposal is to equip these 100,000 aircraft with Geiger counters and require single-engine pilots operating under VFR flight rules at 3,000 feet AGL and below to squawk the radiation level indicated on their Geiger counter when it exceeds 5 times background. Modern-day Geiger counters register radiation in terms of the international standard microsievert. 99.9% of all light single flights today would be conducted at less than 5 times background, and the VFR squawk code would remain the standard 1200. For those flights where the Geiger counter indicates greater than 5 times background, for example, 1 microsievert an hour, the squawk would be 1201. For those flights where the Geiger counter indicates 16 microsieverts an hour, the squawk would be 1216, and so on, up to 1277. Here is one scenario where general aviation would save the day. A terrorist buries a spent nuclear fuel rod just a few centimeters under the 50-yard line of an open-air college football stadium. Such a rod can emit 1 million microsieverts an hour at 1 meter. Under the inverse square law, at 2 meters, the exposure is 1/4 of a million microsieverts an hour. At 4 meters, 1/16 of a million microsieverts an hour. At 10 meters, 1/100th of a million microsieverts an hour. And at 100 meters, 1/10,000th of a million, or just 100 microsieverts an hour. During the game, everyone would be exposed to a month's worth of radiation. A referee, hovering near the 50-yard line, would be exposed to a lethal dose. The starting players would be exposed to 12 times their normal yearly dose. Outside the stadium, assuming 18 centimeters of concrete to support the seats, an 18-centimeter inside supporting wall, and another 18-centimeter outside wall, the radiation levels could not be discerned by a police officer standing outside with a Geiger counter because of the distance, shielding, and interference from the background terrestrial radiation. However, a general aviation aircraft half a nautical mile away at 3,000 feet AGL would be squawking 1201. Another aircraft, flying at 1,000 feet AGL overhead, would be squawking 1204 to ATC. A pre-game 500-foot AGL protective overflight, currently prohibited by NOTAMs, would squawk 1216. Another scenario where general aviation could save the day. This time, rather than a spent nuclear fuel rod, the terrorist has obtained some low-level radioactive waste and placed it under the pitcher's mound of a local ball field. The radiation level is 50,000 microsieverts an hour at 1 meter. In just 1 hour, the pitcher would be exposed to 100 times the yearly radiation limit. The infielders would be exposed to a year's worth of radiation. The outfielders would be exposed to 3 times background. Unless the authorities came within 60 meters of the pitcher's mound with their Geiger counter, they would not be able to detect the nuclear waste due to terrestrial interference. However, that same source could be discerned by a general aviation aircraft overhead at 1,000 feet. If the dirty bomb attack were an exploding bomb, general aviation aircraft, rather than being excluded from disaster areas as they are now, could once again save the day. Geiger counter-equipped aircraft should be required to carry white streamer packets to drop upon ATC instruction. Just after the explosion, the white streamers could be dropped where radiation levels are safe. The public would forever associate small aircraft and their white streamers with safety. Finally, the FAA should require every unattended general aviation aircraft to contain within it an 80 decibel keychain alarming Geiger counter. It would deter terrorists from using general aviation airports as an avenue for administering terror. The alarms would notify not only other pilots, but airport ground crews, neighbors, and passerbys to a radioactive threat. Handheld personal Geiger counters have been in widespread use in Eastern Europe since Chernobyl. The cost to Geiger equip the entire United States fleet of single-engine general aviation aircraft would be around $20 million. It sounds like a lot of money, but it would be less than the cost of refueling each of those aircraft just once at today's fuel prices. A small cost to pay for the security and deterrence it would bring. At some point, at some time, a major city will be contaminated with radiation, and a cleanup of that city to current background levels would not be feasible. Educating the public that being 1,000 meters away from a hotspot reduces the radiation level to 1/1,000,000th of that at 1 meter away is key to preventing panic and mayhem. Entire cities need not be evacuated. Just hotspots need to be avoided by pregnant women and young children. Geiger counter-equipped general aviation aircraft could drop red streamers over these limited hotspots, giving pregnant women and young children notice of places to steer clear of. To recap, a radioactive incident is going to happen. Whether it is an exploding dirty bomb attack, the silent radioactive bomb, or an accident, people will be hurt if we are unprepared. Our task is to educate the public and to create a means of informing them of danger, or the lack thereof, during times of panic. Geiger streamer-equipped general aviation aircraft can deter the terrorist, detect accidents, and prevent mayhem by providing visual clues during times of radioactive panic as to where to go or where to stay. God bless America.